Hi guys. Hi guys. Okay, how are you all? I did not assign homework. Nobody pointed that out to me. I feel very sad.
Oh, I thought you were gonna send it, so like I just waited.
Yeah, same. Like I was waiting for you to post it because I thought because normally you like post it
I
on Monday
honestly
or
forgot.
something.
I honestly forgot. Okay, but just remind me, guys. Okay, always. If you had reminded me, I honestly did not see as well. Okay, there's many. It's too many things I forgot. Okay, but you know what? I'll split it out in such a way you're not overwhelmed. But I will assign somehow chapter 19. Okay.
Miss Priya,
Yama.
this is class now in 30 minutes.
Yes, please. Can we
Okay.
please do that?
I have to leave like 15 or 10 minutes early because I have to go out somewhere.
Okay, as long as you follow, I don't have any problem with you, Ashvik.
Okay.
Okay. You're working out and you're working out all the problems from the book, right?
Yeah.
How are you all doing with Alchemist? Are you all doing Alchemist?
Mm.
Okay. Would you mind, meaning if I give
Sometimes
you an assignment, uh-huh, go ahead.
I
Okay,
do it sometimes.
if you do it sometime. See, the thing is, if you do alchemist, your base will be so strong along with what we are doing. So for the alchemist, can you provide me a screenshot of your algebra, whatever you have? I will create that as an assignment. Would you mind attaching the screenshot as your done thing? Can we do that? For this week, I'm going to have an assignment alchemist, algebra, status. So you're going to attach a screenshot of where you are. I want to see of each of yours. Can we try that? Can we try that?
Sure.
Okay, whatever you have, don't worry about not having something to blue or having so many reds, does not matter. We will equip ourselves on that as we move forward. That's the intent. Okay. Now, let's see this one. We were discussing exponential functions. I will continue discussing exponential functions, and I also want to touch polynomials. Let's see where we go. I'll see. How about, do you know how to plot this? Write the domain of this? That's an easy one, right? Exponential functions are functions where your variable is an exponent. The variable itself becomes an exponent. We did discuss this last week, right? What does this mean? What does this mean? What is the difference between the two? Let me change it a little bit, guys. Okay. What is the difference between the two?
Would the first graph be increasing and the second be decreasing?
Yep. First graph is an exponential growth. How? Why do I say that? The number 4. Think about this. I put x equal to 1. I have this. Then I put x equal to 2. I have this. Then I put x equal to 3. I have this, right? Then I put x equal to 4, I have this. So the original number 4 is getting multiplied by 3. The second time the original number 4 is getting multiplied by 3 two times. The third one, the third sequence in the pattern, this term in the pattern, the original number 4 is getting multiplied by 3, 3, 3, 3 threes. Again, the original number 4 is getting multiplied by 4 threes. Whereas, in the second one, the original number 4, first when I put x equal to 1, it's getting multiplied by 1 by 3. When I put x equal to 2, it becomes 1 by 9 or 1 by 3 times 1 by 3. Whenever you multiply some number by a fraction, the value reduces. Again, you multiply that number by the same fraction, it becomes 4 by 9. If you put x equal to 3, 1 by 3, 1 by 3, 1 by 3, it becomes 4 by 27. See, this is an exponentially decaying sequence. This is an exponentially growing sequence. Any questions here? Now, I am going to give you this and I am going to ask you to try what this entails. What is this, guys? You know 4 3 power of x is an exponentially growth function. 4 1 by 3 power x is an exponentially decaying function because you keep on multiplying by 1 by 3. But can you guess what this is, anybody, based on the transformation we have studied?
Wouldn't it be flipped across the x-axis?
Yeah, flipped on what?
The x-axis.
Why? Why is that?
Because it's negative.
Because it's negative. So let's see, which graph is going to be flipped? This graph or this graph?
First one.
First one.
The first one. Because of this negative, see what happens. I'm going to show you literally. Minus 4. 1 second. Sorry guys. When I have this one, right, I'm literally going to show the graph. See here, the best way to draw any graph is draw a table, have some values, negative values, positive values, minus 4, minus 2, 0, 2, 4. I plug that into my x values, so it becomes minus 4, 3 to the power of minus 4. That becomes minus 4 divided by 3, 3, 3, 3, 81. Similarly, this becomes minus 4 by 9. This becomes minus 4. Then minus 4 times 9 minus 36. Then minus 4 times 3 power of 4, which is 81. Something like 324, minus 324. So when I graph this, you can clearly see minus 4 is a minus 4 by 81. Minus 2 is a little bit higher. And then, let's see. Okay, 1 second guys. I'm doing it on the positive side. Hold on. So, minus 1, minus 2, minus 3, minus 4. Here, 1, 2, 3, 4. Now you have 3, 4. Off point. When you get to minus 1, minus 2, minus 3, minus 4, minus 4 is minus 4 by 81. This is going to be here. Minus 2 is minus 4 by 9, which is a little higher. Sorry, minus 1. I'm sorry. 1 second, guys. I'm sorry. Okay. Minus 1 is going to be a little higher, right? But less than 1. And then minus less than minus 1. And then 0 is a minus 4. See how steeply it increases. And then minus 2 is going to be a minus 36. See what happens to the graph. Do you see, guys? So basically this minus negates your y value. Suppose let's consider a point 2, 1. If you flip it, if you flip the point on the x-axis, see what happens? This point becomes 2, minus 1. When you flip it on the x-axis, your y value gets negated. If you flip it on the y-axis, what happens to the point? The point becomes minus 2 comma 1. If you flip it on the y-axis, did you see what happens? Your x value gets negated. Any questions? A point, even the same thing happens. If you flip it on the y-axis, x value gets negated. If you flip it on the x-axis, y value gets negated. Clearly here from your parent graph, the y value got negated. That means the graph, this graph was flipped on the x-axis. Did you guys get it? Any questions? Okay. Okay, now let's move a little bit further. Ashwin, what are you discussing in school, Ashwin?
In school, I think we're doing like exponential growth and decay.
Oh, okay. Okay.
Yeah.
Nice to know. Okay. Now let's see this one. Mm. 1 second, guys. 1 second. Okay, let's see this one. You're able to do this? Can you do this one for me? This is a part of what we have done last week. Not on graphing though. Let's see whether you're able to do. I can do it on the board, but once I get some answers, I'll do it on the board. Mm.
Miss Priya, I sent my answer.
That seems right to me. Pi power of Tisha, okay. Yeah, Johan, that seems right. Ritisha, can you check once? Because I got Johan's answer. Anish, check again, Anish. You have to be careful with something, Anish. You're just overlooking that. Ashwik, I'm not getting your value. I'm getting Johan's value. Ah,
Our
Sham.
answer.
No, not really Sham. See, what I have seen now is, okay, including me, we are 6 people and 6 different answers. I'll tell you what are the answers that I've come across. 1.25, 2, 3, okay, -2, and half. Funny, right?
Awesome.
Oh, now 5/2. Oh my goodness. Each of us are getting one value. Okay, Ashwin, what did you get?
I'm still solving it out.
Okay, I'm going to wait for you. Swarit, what did you get, Swarit?
I'm still doing it.
I don't know actually. Let's see. 5 power of -4 equal to 5 power of 48 by x divided by 5 power of 50 and 3, 4, 5, 60 by x. Oh my god. Okay, I don't know, guys. Then I mentally calculated it as 50.
Miss Priya, is that a new answer?
You change your answer. Okay, let me see, ma. -4, 5 power of 48 by x minus 60 by x. So that would be 5 power of -4 will be equal to 5 power of minus 12 by x. So I can equate.
Yeah, some on your answer.
Sure, ma. So -4, 3. So, so clearly I was on the incorrect path. Unless I do it, I didn't get it right. Okay. I mentally did it and got 2. Ritisha, you corrected. Sham, you corrected. Johan, you corrected. Dia was correct right from the start. Ashwik was correct from the start. Swarit, Ashwin, I'm waiting for you. I will wait for you.
I got the same answer.
Oh,
It's the
yes.
same thing.
How about you? How about you, Vishnu Ram?
I got x equals 3.
Okay, good. Okay, guys. Okay. Just let me know what is your thought. Do you all want to continue AOPS geometry or school based geometry? Johan, that might not be a question for you, but for the others. Would you like to continue? I'm really asking, guys. Please let me know each of your priority. I would like to know. Huh?
I think AOP's better.
Okay. Anish, Swarit.
I think
Yeah.
Swarit, what is your choice?
Like between what?
Between
The
AOPS geometry or school based geometry?
AOPS.
How about you both, Ashwik, Ritisha, Dia, and Vishnu Ram and Sham?
AOPS.
Yeah, AOPS.
AOPS is better because like it's basically what we learn in school, but like a bit more advanced. So we already know like stuff for the future.
Okay, that's good. Okay, I value each of your input. Dia, Ashwik, how about you?
AOPS.
AOPS.
Okay, guys. I just want to know because in another 3-4 weeks we'll complete this completely. I feel. Okay, that's fine. We'll move on with AOPS geometry. I think it's unanimously AOPS geometry. So, okay. Now let me go ahead. What did I want to do? Okay, now, do you know the difference between simple interest and compound interest? How many of you know?
I know.
Okay,
I do.
so how does it grow? Do you all know? How does it
Yeah.
grow?
Compound is exponentially and simple is just the same
Like multiplication or linear.
linear, yeah.
Yeah, take $100. Okay, so let's say I'm going to go with simple interest and compound interest.
Yeah.
what I'm writing, interest, compound interest. Okay, first you need to understand how this money grows. This $100, year one. Okay, simple interest. What happens is the interest is calculated using both work the same way, but I'll tell you where is the difference.
So what's the interest rate?
Yeah, let the interest rate be 20%. Nobody's going to give you 20% in reality. I'm giving you 20%, okay? 20% is the interest rate. Now, let's say for only 1 year, right? The interest is calculated using PNR. PNR means principal. Principal is your $100. PNR, number of years is just one. Rate of interest is 20 by 100 is nothing but 1 by 5. So you're going to get $20 as interest. You know what happens in simple interest? They give back this $20 to you. Okay. The year two, when it starts with $100. Any questions? This $20 comes to you. Now again, the interest is again $20 when you look at it, because the principal was only 100, right? 20. So this is again given back to you. Again, in year 3, the principal came to 100, because the principal is getting retained, and the interest becomes again $20. At the end of year 3, you get another 20. Suppose I want to stop here, I don't want to proceed. So how much did you earn? Your original principal was 100 and you also earned $60, making it a total of $160. Any question till here? Whereas in compound interest, let's see what happens. You started year 1, okay? The principal was $100. The same, see, interest became again PNR only. Principal, number of years, rate of interest. So that was $20. Now, what happens, they don't give you back. Compound means everything gets accumulated. So the bank, what does it do? In year 2, they don't give you back anything. Till the end of year 3, they're not going to give you anything. You're putting the money into the bank and asking them to give it back to you at the end of 3 years. So this principal will get added with this interest and it becomes 120. So now the interest becomes 120 is your principal times 1 by 5. So what happens here? $24. You see how the money grows. Now in year 3, what will be the principal? 120 plus 24, 144. The interest is 144 times 1 by 5. So that becomes 5 8s are 40, 5 8, 28.8. Oh wow, see here, 28.8. Now see what happens at the end of year 3. What is your earning? 144 plus 28.8. What is that? Do you see the difference between simple interest and compound interest? So the money gets accumulated. The power of accumulation is so huge. So guys, you're all so young. If you really want to become so rich, you should really exploit this compound interest. When I was so young, I did not know the power of compounding. Okay, so if you put in money for a long period like 20 years, 30 years, right, which you have a lot of time more, right, upcoming time. So if you start investing even $100 now with years, right, that really grows so well and there is exponential growth of money. Whereas if you don't invest at all, the principal is never going to grow. If you put it in simple interest, the growth is so less. Makes sense, guys? See, this is only for 3 years. Think of it for a longer time span of 20-30 years. Automatically, compound interest is amazing. The extent to which the money grows is so large. Any questions here? Okay. Now, let's see how we are going to use the exponential function. Okay. So I told you about simple interest, compound interest. Let's see. Okay, how about this? See, interest is calculated using PNR. P is the principal, N is the number of years, R is the rate of interest. Rate of interest is always in percentage. So can we try doing this problem from the book? I just want you to do number C and D. I don't want you to do the rest. C and D. Can we try that? Uh, those of you who are learning algebra 1 at school, Swarit, did they finish simple compound interest for you?
Uh,
Not
I
yet?
don't that. Well, we did in 7th grade math.
Oh, yeah. Okay, correct. Sorry, yeah. Correct. Well, this is a nice way to understand. This book is so good, guys. Okay, let's try this out.
Miss Priya has my answer.
Uh-huh. I really want to explain this to you well. Okay, let's see this one. We'll take time on this. Yes, Ritesh, I'm checking. Yep, Ashwik, good job. 54505,900. I am stuck, guys. Something is not correct. 450 yen. Is that the answer? 0. Yeah, Sham, that seems right to me. Anish, is your D answer right? Let's find out. There is something wrong, I feel. Some of your answer just say 450 yen. Okay, I got what is the problem. Okay, Johan, Jane puts 5,000 in investment, right? She puts 5,000 in an investment that earns 9% compound interest, 9 by 100, right? And then for 3 years, right? This is your simple interest, great. Okay, so that, I think everybody got this. 9 3 27 times 50. 1350. This one everyone got. This is good. But then at the end of n years, right? 5,000. That's your principal. This is your interest you're calculating. Okay. But at the end of 3 years, how much will you have? This is your interest you earned. But then you also had your original 5,000. They're asking, please read the problem. Okay, simple interest, how much you have at the end of seed. Okay, maybe that's off, but then they're asking you to calculate. 1 second, guys. I really want to verify that. What are they asking?
It says at the
And
end of 3 years. It doesn't say that the whole thing ended at 3 years. It just,
how much will she have at the end of? How much
yeah.
will she have at the end of n years means you should add this. So this will be 6350. And then
Mm,
at the end of n years, it will be 5000 plus 450n. Make sense? Total amount they're asking. So this is the total amount. This is the total amount after 3 years. Make sense?
Yeah.
Yeah, but like you said that they receive the money, and then at the end of the thing they get all the money back.
Yeah, correct. The principal needs to be added, right? Total money she has at the end of means you should also add the principal, right?
Oh, yeah.
Make sense, Anish?
Okay.
Okay. Now, if it is compounding, let's say the same thing, right? I really want to compare with compounding. So this one you understood. 19.7. 1 second, guys. Okay. Let me say I invest K dollars at the rate of R% for n years. Suppose I invest K dollars at R% for n years. Do you think you can calculate the simple interest? Total money. So now everything, you are arriving at a formula. You are ending up arriving, I mean, you're going to arrive at a formula. So what I want to know is the money she would have at the end of n years. You're going to calculate a formula. Literally, you're going to derive the formula. Derive the formula for n years. Would you be able to do this? For total money she has at the end of n years. You think you can do this? You can do that?
Is this for compound interest or simple interest?
This is only simple interest, ma. We are arriving at a formula for simple interest. Meaning it's just practical knowledge, okay? Nothing else. This one.
This.
Okay. Oh, wow. Uh, take it as R by 100, R%, right? Johan, you forgot. That is R%.
Yeah.
Percent means divided.
Okay,
So
I'll
you
fix it.
arrive at a formula.
Miss Priya, I sent my answer.
You sent your answer, Ritisha. But Ritisha, how did you derive this, Ritisha? There's no way you will get this. How did you do this? We are working on simple interest, right?
Oh, I thought you said compound interest. I'm sorry. That's my
No.
fault.
We are not yet there, right, Ritisha? I really want you to be able to understand the formula and do. Yeah, Ritisha, can you take out K as common?
Okay.
Ritisha, you cannot give me formulas in terms of percentage and all. You have to do the percentage.
I know, but like I wrote in percentage because like what if it's like 40% or 0 point or like 9% because those are different decimals. That's why.
Yeah, it doesn't matter, but R is a variable you can use for that. But R percentage means divide by 100 is there. You see what I mean?
So it'd be R over 100, right?
Correct.
Okay.
Johan, can you take R as common?
Okay.
Swarit, I asked derive the formula for the total money at the end
Oh,
of n
my.
years.
I sent my
So
new answer. I sent
let's
my new
see.
answer.
Interest at the end of
Oh,
1 year. Okay, Anish. Interest at the end of 1 year is P. Principal is K, N, R. Right? Now, interest at the end of n years is this, right? So KR by 100, KRN by 100. That is the interest at the end of n years. But your original K principal will get added to the total money, right? Amount at the end of n years. Amount at the end of n years will be K plus KRN by 100. But if you take out K as common, it will be 1 plus RN by 100. Any questions here, guys? Any questions? Now I have more questions. Simple interest is so easy, but let's see. Suppose the same lady invests 5,000 in an investment that earns 9% interest. Let's see. Let me give you the problem. Okay, let me give you this problem. Do this one. I just want the answer for. I just want the answer for 3 years and n years. I will do it on the board, I feel. Suppose $5,000 she's investing at 9% interest and it grows and it is compounded annually. Compounded annually means per year once she's compounding. So initially she had this 5,000. So at the end of year 1, what happens? This 5,000 gets multiplied by 9 by 100 times 1. So you get 9
450.
450, right? Now year 2, again the principal changes, right? So basically 5,000 times 9 by 100 is your principal. That again gets multiplied by
0.
this is uh, okay, basically this is your principal. Principal becomes, this is your interest that you earned. The principal becomes this, right? And then that gets multiplied by this is your principal. Okay, now 9 by 100 of that plus 5,000 will be the money you earn. Does that make sense, guys? Whatever I am doing, does this make sense?
Can you explain it better?
Yeah, sure. I was in a hurry, right? Now, the first year, did you get 450? First year, you got
Yeah.
450, right? Now, what is the principal for the second year? 5,450?
No.
Yeah, because
Wait,
the interest gets
yeah,
added.
it is.
So that's what I wrote down. Now, this is my principal, but what is the interest earned in the second year? 9% of that amount, correct?
Yeah. Do you add that?
Wait. This is my total interest earned for year 2, but the money that you have is your original principal plus this, correct?
Yeah.
Am I making sense?
Wait, so you do 5,450, like you find 9% of that and then you add it to 5,000?
Yeah, correct. Because the
Okay.
principal grew. That grown principal, 9% of that plus 5,000, correct?
Yeah.
Now, when you think about it, what is your principal? Same 5,000 plus 450, 9 by 100. This is your principal, right? The entire
Yeah.
thing is your principal for year 3, right?
Mm-hmm.
Now, year 3, what will be the interest you earn? 9% of that plus your initial 5,000. Does that make sense?
Oh, yeah.
So it keeps on growing like this. Do you see for year 4, I can copy the entire thing. It's going to become large and large such that you don't understand what's going on. 9 by 100 plus 5,000, 9 by 100. The entire thing is going to be your principal, right? Plus 5,000. This is your principal, but then 9 by 100 of that is going to be your interest plus 5,000. Does that make sense?
Oh, can you like write the formula down? Is there like a formula?
Yeah, I don't want to write the formula. I want you to derive the formula. That's why I wrote this.
Oh,
You got it? See, if I just give you the formula, you will never understand how the formula came. Okay, so see how the compounding works. Compounding is a little bit complicated, right? So let's see this one. I'll make it a little easier on you.
wait, so if
Now,
you keep adding years, does it like grow even more like the equation?
yeah, I'll tell you how. For year 1, right? What is this basically? What to say? Okay, at the end of year 1, right? Amount at the end of year 1, how do I write it? Can I say it grew by 9% means what is the amount at the end of year 1? One of you tell me. It grew by 9% means what is the amount? Some amount, okay, that
So
grew
the
by 9%.
so like the principal is like like the starting value.
Yeah, don't worry about it. Yeah,
Okay.
what I'm asking you is if some money grew by 9% means how do I write the amount? What will be the amount I get
Would
at
you
the end of the
like,
year?
would it be 1.09 of it?
Ah, good job. It will be 109% of the original principal. Does that make sense?
Yeah.
Okay. Then amount at the end of, see, this is so hard for me to follow,
Oh,
right?
wait, so in like the second year it'd be 118?
Ah, it won't be 118. Instead, what it would be? This would be your principal. Whatever I'm writing. Guys, I'm going to write it in decimal. It's
Oh,
so hard.
and oh,
No, no, let me write it down. This is 1.09 I'll write. Now, for the second year, let me write down this is my principal, right? That
yeah.
will get multiplied by 1.09. Does that make sense?
Oh, yeah, that makes more sense.
For the third year, what happens?
Uh,
This
so
would be my principal, meaning 5,000 times 1.09 power 2 will be my principal. That gets multiplied by 1.09. Does that make sense, guys?
so it keeps growing like that. Okay.
Yeah, keeps growing not as addition here,
Yeah,
but
it's like
as multiplication.
multiplication.
And it becomes an exponential geometric sequence. When you think about it, the original 5,000 was the first initial value that I had. I keep on multiplying by 1.09, 1.09. Again, see, the common ratio becomes 1.09. Does that make sense? So
Mm-hmm.
finally, for the year for 5,000 times 1.09 power, does that make sense?
Oh,
For year
yeah.
4.
For
For
year
year
4.
n, what happens? 5,000 times 1.09 power n. Am I making sense?
Mm-hmm.
Now, I will delete everything and I will say, hey, amount at year n, amount at the end of n years will be the principal. Let me write down whatever we had. 5,000, 1.09 power n is what I said. In a different way, what I can do, I can write down the principal as P. I will write this out as 1 plus 0.09 power n. What was this 0.09, guys?
The interest.
The rate of interest, right?
Yeah. So R divided by
100, R divided by 100 or R percentage, right?
yeah.
Power n. So this is how you derive the formula
Oh,
for amount n. Compound interest formula you studied last year, but by memorizing. Right? Don't memorize. This is how you got the compound interest formula. You got it?
Mhm.
Clear, guys? Now I'm going to give you another scenario. Ashwin, are you following Ashwin?
Yes, auntie. Yeah.
Siddharth, are you following? I'm sorry, Shyam, are you following?
Yes.
I don't know when I'll stop calling you. Sorry. Okay, now, let's say, what did I want to say? I forgot. Oh my gosh.
Wait, what's the n again?
You tell me what is n again.
Uh,
I'll help you. Don't worry. I'm not putting you under the bus. Tell me what is n.
like the years.
Yes, number of years.
Uh,
Okay, suppose now I buy a stock. Okay, I buy a stock for $100. Okay, the stock deteriorates. The stock value deteriorates. Let's say, or guys, I want a similar scenario. Okay, I buy a stock for $5,000. I buy a stock for $5,000. Okay, the stock deteriorates, goes down by 9% every year. What do you think will happen to the formula?
Oh, P times 1 minus R by 100 to the power of n.
P times 1
1
minus
minus
R by
R
100
by
power of n. Do you guys get it? You know why
Yeah.
that happens? You know why that happens? For the first year, it will be 5,000 times. It won't be 1.09. If it reduces by 9%, it will be 0.91. For the second year, it would be this is your principal. This is your principal times 0.91 because it keeps on deteriorating by 9%. For the third year, your principal will be this is your principal times 0.91. You see, it goes on deteriorating. So this one can be written as 1 minus R by 100. Am I making sense? So this is whenever something grows exponentially, it is exponential growth, and you can use this formula to find out. What you can find out? You can find out the total amount. If it is dollar money invested, you can find out the total money invested at the end of what total money you will get at the end of n years using this. Suppose a stock, it goes on reducing by 9%, 9%, 9%. Then the value of the stock at the end of n years can be calculated using this formula. This is exponential decay. Any questions, guys? This will come in algebra too. Okay, that time I'll ask you. I won't derive the formula then. Okay, this is exponential growth. This is exponential decay. Any questions here?
No.
Now, this I am compounding. See, here whatever I did was I compounded annually. You see what I mean? Per 1 year, in 1 year, I compounded only one time. That is why it became 1.09 times my initial value. Suppose if I start compounding 2 times a year, what happens? If I start compounding 2 times a year, within the first 6 months, what happens?
like 2
Within the
times.
first 6 months, your principal becomes this, but it'll be divided by 2 as well. So basically, yeah, so what happens here? If you start compounding annually means once per year. But if you, first of all, okay, so exponential decay growth, you understood how the formula comes. Now, what I'm going to do is, I'm going to compound it 2 times a year. That's going to make it a little more complicated. If you compound it 2 times a year, let's say what happens? After 6 months, right? I'll tell you. I'll go back. I'm going to erase this off. I'll ask you for the formulas later. Okay, now I'm going to compound it semi-annually. Semi-annually means 2 times a year, right? Now, what is the interest first of all? Interest for 1 year, right? 5,000 times 9 by 100 times 1. This was 450. Unfortunately, this is for 1 year, right? For 6 months, what it will be? This is 1 year in half of that. What is half of that? It's going to be complicated. I'll explain quickly. Let's see. 2, am I doing it right? 2 to the 4, 2 to the 4, 1, 2, 5, 7.
220.
Okay. Yeah, the problem is this gets added to this 6 months get added to your principal. So 5,225 is your principal for the next 6 months. You see, within that 1 year itself, it undergoes a change. This 5225 gets multiplied by 9 by 100. But again, this is not for 1 year. First, let me calculate for 1 year and then divide by 2 again. So when you think about it, what happens here? Let me quickly find out, guys. Approximately, at least I want 9 5s are 45, 4 9 2s are 80, 9 20, 21 22, 2 9s are 80, 9 22 are 45, 46, 47 divided by 100, 470.25. Am I making sense? Something feels wrong to me. Okay, 47, yeah, correct. 470.25 divide by 2. 2, 3, 5, 1, 1, 2, 5. You see, now your principal at the end of 1 year, see, this one I divided by 2. This is 6 month interest, this is 6 month interest. Now I'm going to add that 235.125. So now your principal becomes what? 5460.125. Does that make sense? It grows or it lessens. By compounding it semi-annually, your principal for the second year grows or lessens. Compounding it annually, what happened? If you had compounded it annually, your original 5,000 would have gotten added with this 450. So the principal for the second year would have been 5450. Just because you compounded once in 6 months, what did they do? 6 months interest, they put it as the principal for the next 6 months. As a result, the second 6 month interest was drastically different from the first 6 months. As a result, at the end of 1 year, your principal grew 5460.125. So which is better? Compounding it semi-annually is better or annually is better? Semi-annually is so much better. Suppose, let's say you compound it for 4 times in 1 year. Which will be better? Semi-annually or 4 times in 1 year? Quarterly is better.
Quarterly.
4 times is better. Think about this. Suppose you start compounding every day. The bank starts compounding your interest every day. Which is better? Every day is better or quarterly is better?
Every day.
Every day is better. Suppose if your bank starts compounding every second, right? That's so much better. Do you see? So the number of times they compound really has an effect on the interest or the amount that you earn. Okay, now let me see. I want to show you something. Let me show you that. Suppose they compound it for, the formula becomes a little different. Our original formula was P times 1 plus R by 100 whole power of N for annual, right? Now if they, let me say this is the amount at the end of N years for compound interest. Now amount at the end of N years, let's say they're compounding M times per year. M times per year compounding. You know what happens? This becomes 1 plus R by 100M power of Mn. So the M, right, number of times you're compounding, right? The formula gets changed. I don't want you to show that. It's going to really take time, and I'll tell you this directly. So here for compound interest, if it is annual, it's going to be this. This we derived. Suppose if they are going to compound M times per year, the formula gets changed a little bit here. Power M, meaning M is the number of times they compound in 1 year. So the formula gets slightly changed. Any questions here? Any questions here?
No.
Oh, wait, so I have a
Okay.
question.
Yeah, go ahead.
So if they're doing semi-annually, right? Would M be 1/2 or 2?
M will be 2.
Okay.
You see, meaning it's going to go up. So semi-annually means 2 times compounding. M will be 2, 4 for quarterly. Got it?
And
Every
even
day
if
means
it's
365.
even if it's decreasing, like I mean, if it's p times 1 minus r to the by 100.
You know what? This one, right? We are only working on exponential growth.
Mm.
Okay. You see what I mean? We are only working on exponential growth, and how money multiplies is the main thing that we are learning here.
Okay.
Make sense?
Yeah.
Okay. I want to bring this up to you. Wait. This is usually taught in algebra too, but I really want you guys to know this. Wait, let me show you something. Okay. Uh, 1 second, guys. So we have the formula here. One second. So 1 by n. Okay. Um. One second, guys. I want to bring this up to you. Okay, so basically, I don't want to relate anything now, but see, when 1 plus 1 by n power n, this particular value, right, as n grows larger and larger, leave this in here, leave it in here, but I want you to introduce to a concept called Euler number. I want you to get introduced to the concept Euler number. Euler was a mathematician, okay? Here, what he did was, he just computed. There is a function like this, okay? This function is very similar to this one when you look at it, okay? That's why I want you to get exposed to this. Here, this function, f of n will be equal to 1 plus 1 by n power n. When you think about this function, I'll go to the table. When you think about this function, see, this function becomes this. Okay, the f of n is 1 plus 1 by n power n. Okay, put n equal to 1. That's what they have done here. Put n equal to 1. F of 1 will be equal to 1 plus 1 power n equal to 1, right? 2. Put n equal to 2. F of 2 will be equal to 1 plus 1 by 2 power 2, which is 1.5 power 2, right? 1.5 power 2 is 2.25. Does it make sense? This function is completely separate from what we are learning, but there is a relationship between the two. You can learn that in algebra too, but I want you to know that compound interest, when it grows large and large, is related to the Euler number. When you think about this function, right, this function becomes this number when the n value is really large. This particular number is very significant in mathematics. The mathematician Euler said, hey, let's call this decimal 2.71828169. Let's call this number as Euler number. Okay, so anywhere, wherever you have this 2.7182816, so this number is called E in mathematics. You know what? Wherever you come across this E, that's not a variable. The value can be substituted as 2.718. Any questions? See, f of x equal to 2 power of x is an exponential function. f of x equal to 10 power of x is an exponential function. F of x equal to e power of x is an exponential function. E is not a variable. X is the variable. What is e? It's 2.718. Make sense? It's completely a different type of exponential function. Here 2 is being raised to the power of x. Here 10 is raised to the power of x. Here e is raised to the power of x. Any questions? E has a value to it. It's not a variable. It's 2.718. Make sense? It has got a lot of implication in algebra 2. We'll learn it later. Can I move on? Okay, now how about this? Okay, I'll give you this. Send me the answer and we'll move on. Okay, this one you can calculate based on all the formulas that we read. Try this one. You can use a calculator for this one, please. You can use a calculator for this one. Let's see how much we can do. Go ahead. I'm not going to go into logarithms, guys. I'm going to go back to polynomials, okay? I'm going to go back to polynomials after this. I'm not going to get into logarithms, maybe next or the next week only. Did anybody get it? To the nearest tenth of a percent you can calculate.
That's our answer.
Okay, see, yeah, that's right, Ritisha. You get it? Would be nice to get all your answers, please. Certain things I'm skipping in this book, guys. Not everything we are solving. See, 19.2.5 is a derivation that we did for n years. 19.2.6 is the derivation you have to do if you compound m times a year.
That's the answer.
Yeah, Johan, correct. I would like to do one more of this and then only move on. Let's see. This is a good one. Okay, let's see, guys. Okay, let's see. Yeah, correct. Vishnu Ram, correct. Shyam, correct. Swarit. Swarit, no. Why did you get 30%, Swarit? Can you redo?
Yeah, sure. Oh, wait, it's
Anish,
compound. I did simple.
simple, huh? Okay, okay.
Yeah.
Okay, as long as you get it, I'm fine. So now I really want you to understand something here. Let's see. Here, guys, we discussed that the amount at the end of n years, right, will be equal to, suppose if you invest P principal 1 plus R by 100 whole power of n, this was for n years compounded annually, correct? Now, suppose they might ask you the same question in a different way. Your money grew to 3 million. Let's say this money is 3 million. Okay. And you have time of 10 years. You have time of 10 years and you know that your money will grow at the rate of 5%. What will be the money you need to invest now? This is the present value of a future $3 million. Am I making sense? Future, I want to have $3 million in 10 years. Okay, I know my money is going to grow at the rate of 5%. Then what is the money you need to invest now? For that question, literally, you need to find out the principal, or the current principal, right? So that will be the future money that you're expecting divided by 1 plus R by 100 whole power of n. Does it make sense? P is your present value of the money you're expecting to get in n years. You get it? So you need to invest this much money to get this much amount at the end of n years if you invest it at the rate of R%. Any questions here? Meaning the same formula can be applied in a different way. That's what I mean. If they give you that, oh, I want to achieve a target of making $3 million in 10 years. I know that my money will improve at the rate of 5% per year. I want to know how much I need to invest today. Then you need to calculate the principal here. Make sense, guys? The rest of it you know. Okay. Any questions there? Vishnu Ram, did you understand that?
Yeah.
Okay, let's see this one. This uses that. Let me see. Let me see if you're getting it. If you didn't, I'll help. You have to shout out and ask though. So I don't want to go to logarithms, okay? So you can do till 19.3. I want you all to do 19.1, 2, 3 this week. But I'm going to go into polynomials. Polynomials is which chapter? I want to go to polynomials quick. Only if we rush through, meaning if we keep on moving, not wait for the next week, we'll be able to finish the book properly. Let's see. Polynomials is which unit? Okay. 18th unit. Okay, in school, did somebody cover polynomials, guys? In school, did somebody cover polynomials at school? Yes, no, you have two answers, you know.
Doing what with them?
What
Like
is it, ma?
anything? Is there like anything specific with polynomials?
No, addition,
That's
subtraction,
fine.
multiplication, division of
Could
polynomials.
I
Have you started
Oh,
could I go
yeah, I just started that unit.
at school?
could I go to the bathroom?
Yeah, please go ahead and come back.
Yeah, at school I just started that unit.
Okay. Okay, we'll have an intro to polynomials. Let's see. The correct, ma. Okay, shall we move on? Did you get that? What should be the initial amount? If you guys know how to do it, I'm going to move on. And I also want to cover one more thing. Let me go to the Algebra 1 book that I do it in school. Not this one. Algebra 1 school. I want to cover one more type of problem. Polynomials, if I don't have time, I can do it next week. Let's see. But I want to cover that thing that I want to. It's a type of problem where you need to use a calculator. I don't know how many of you know, so I want to cover that. Let's see. In how many years it will grow? Let's see. Not this one. I want to go to chapter 12. Yeah, constructing geometric sequences and exponential functions. Yeah. Yeah, this is a good one, but I want to find the problem that I want to give you. Did you guys get it? Did you guys get it? Polynomials I can start next week. I want to do one more type of problem. Sorry, 376, 889. Yeah. Ayyo. So see, decimals you need to be careful, guys. Yeah, Johan, your decimal placement is incorrect.
Oh, I just rounded it up to the nearest dollar.
No, to the nearest?
To the nearest dollar?
Nine. No, even then that's incorrect. Meaning there is one more number, there's one more digit to your answer.
Oh, maybe I just made a typo or something.
Yeah, if you're good, I'll leave it to you. So 376889 should be your answer. 376889 should be your answer. But you have a 5, right, Johan? That's why
Yeah,
I'm
I
saying.
probably just misclicked that.
Okay, so you got it now. I'll leave
Yeah.
it. Dia, did you get it? Okay, this is one problem I really want you guys to do. No, not this one.
Miss Priya.
Yeah, Yama.
I
You
have
have
to
to.
go.
Okay, the last one alone, Ashwik, I really want you to know how to do this problem. This is not in this book, but I really want you to be able to do this using a calculator. I'm going to explain. You can come back and see there is no hurry, but at the same time, I want you to understand that. With this explanation, I'll stop the class. You can leave, but please do see the recording or try to understand how to do the problem. Make sense?
Yeah, thank you.
Yes, Ashwik. Bye bye. In 2000, the population of Massachusetts was 6.3 million. Okay, and was growing at the rate of, so you know the initial value. Initial value. See, this one is not hard. Exponential functions, but it's not hard. But doing it in the calculator, I want you to know. 6 million. Okay. Now, the growing at the rate of 0.32%. This growth rate, the function becomes 6.3 in millions, okay, and then 1.0032. Do you see this is an exponential growth function? Where did this 1 come from? 1 plus r by 100, right? That's what they have given here. Okay, now using this model, when will it reach 7 million? How to do this, guys? This should become 7. How do you do this in a calculator? Do you all know? You have to find out x. How do you know? Meaning, how to do this? Anybody can pop in answers. Anybody can pop in suggestions. How to do this? I want you to find out the number of years in which it will reach 7 million people. When? How?
6.3 like times 1.0032 like adding something.
Yeah, but there is an exponent here. How will you solve for x? This one
Don't we first like divide everything by 6.3?
Good job. Divide everything by 6.3. After that, what happens? I want to find out x, right?
Then don't we
You take the root of x from both sides?
yeah.
But I can't take the root of Meaning, you see what I mean? Yes, that's true. But practically, how will you solve it in the calculator? There's no square root of x in the calculator, right?
Yeah.
So what do we do? You would have solved this in school if you've completed exponential functions. You should have. How will you solve this, guys? I honestly am expecting this class to
Would you graph
already have the
it?
answer. Huh?
Would you
Would you
graph it?
graph it? Good job. But how will you, okay, when you graph it, you know how to graph this in the calculator? How do you graph this in the calculator? Correct. Only by graphing you can find out, unless you know logarithms. This is the only scenario or only type of problem which comes in algebra 1, but that requires logarithm. But you won't cover logarithm in algebra 1. So how do you solve this? So only by graphing. Graphing is the only way. But how to graph this, right? So one of you please note down this number. I'll go ahead and show you quick and then you can log off. Make sense? 7 by 6.3. So this one, how to find out x, right? I'm going to stop screen share. You please note down. I'm going to go to TI-84 calc because I see this one. Huh?
Is the answer 2033?
Is the answer?
2033.
That is correct. That is almost correct. But what did you get for x?
X, I got I got 33 years basically, if I round it.
You got don't round, ma. Don't round in these. Please don't round. That is the only issue, I think. How did you get it, Ashwin? Can you explain for us?
I used like equation solver thing on the calculator.
Oh, you know how to do it? Okay, I don't mind at all. If you don't know, just stay on. But Ashwin, you're rounding and that leads to error, I feel. Your answer is almost right, but not exactly right. Okay, can you tell me that equation? Please, one of you. 1.0032 power x will be equal to what?
7 over 6.3.
7 by 6.3.
Okay, that's it, right? So see guys, this one when you graph it, you have no way of finding x. I don't know how Ashwin did it, honestly. What is that you used, Ashwin?
So you have to click like math, I think. Like the math. No, you click the math button. It's like
Math button. Okay, let's go with him first and then I'll tell you how I do. Math.
and then you like scroll all the way down. Like
Scroll all the way down.
I think you could also click alpha and program. You get the same thing.
Oh, okay. Go here.
Yeah,
Alpha and go ahead.
yeah, one more down. One more. And yeah, the one below that. One below.
The one below this one. This
That
one.
one
Numerics.
down. Yeah.
What do you
And
do?
then so you basically type one side of the equation in
Wow,
the top
okay,
box.
like this, huh? See, I did not know this. Okay, so this one power x, huh?
Yeah, then the second box you type 7 by 6.3.
How to go to the second box?
Just like go down.
Okay, yeah, 7. Okay, guys, if you all are comfortable with this, I did not know this.
And then you have to click graph. And then you click alpha, enter.
Alpha,
enter.
enter. That's it?
Yeah, and
32 point. I see, I see. I see. You know what I do? I'll show you quick. Okay, I'll plot this as a separate graph. That's all. 1.0032. I plot it as a separate graph. Power x. So the second graph is 7 divided by 6.3. Yeah, Ashwin, I think your answer is correct because the book answer is different. Graph. See, now you have to find the intersection. Second calc, find the intersect of both because you're graphing both as separate functions. This as a linear function, this as an exponential function. So find the intersect. First curve, second curve, guess. Answer is, oh my gosh. What did I do? I'm sorry. Y will be, sorry guys, wait. So I go here. Y will be equal to 1.0032 power x 7 divided by, okay, and then graph. Then second calc intersection of both is what I need. So first curve, second curve, guess what happens? Oh my gosh, there is some problem. I can check, but I'll go with equation solver. What did you do to go there, Ashwin?
You just click math and then you scroll all the way down and click
Math.
enter.
Okay.
I think another way you can go there is you click math, alpha, and then the program button.
Wait, let's see. Math.
Oh,
Where
yeah.
is math? Wait, guys.
Math
Math. Alpha.
And then program.
and
Program. Sorry, guys. Oh, here. Okay. Here. This one.
No, as in like the one on like the button on the calculator, like the one next to apps. The one,
Oh,
yeah,
this
that one.
Oh, I see. Then exec, huh?
No, I think you like removed the alpha, but like
Okay.
wait, no,
Please tell
click
me.
clear
Clear.
and
I
then click
cleared it.
math.
Math. I did not know this, guys. Math. Okay.
And then click alpha
Alpha.
and just click program.
And then
program.
program. Oh, wow. Okay. Math alpha program. Okay. This is also fine. Then, okay. Then, yeah. Graph. But why does it? Oh.
To solve it, you have to click graph and then alpha enter.
Oh, okay. Okay, I see. Okay, guys, I'll go with you guys. If you know how to do this, I'm fine. Solve. Yeah, but for me, I plot it as two different functions in here and then graph and find the intersect. Anything works as long as you understand how to solve either. Any questions here? Calc. I just want to see how you guys do as well. Calc, I want to repeat, please, for myself to understand more. How did you do Ashwin's way? Calc, math. What did you do? Oh, okay, I'll come here. That was easy for me. Numeric solver, right?
Yeah.
This is all as well fine. Math, numeric solver, and then E1, E2 after that, ma?
No, after that you click graph, alpha, enter.
Oh, graph,
So click
alpha, enter.
yeah,
Oh, I
you
see.
get that.
I see. I see. Okay. This also makes sense. Or you can go to stat plot, do it as a separate function, then go to graph. Okay, but then you need to resize and find the intersect. Resize means you'll have to make sure both the things are visible. So basically this graph is this. This one is a linear function, right? So one of the graph will be, one of it will be 1 point something is a line, and then the other one is an exponential function. So you need to find the intersection point. For that, you need to find out the first curve, second curve properly, and then find out the intersection. You don't need to go here. You can learn that in algebra too. But Ashwin and Johan's way of solving using math is better. Equation solver. Math, go to equation solver and solve. Makes sense? Any questions? This is good for me. I didn't know this. Any questions, guys? Okay, we'll stop here, guys. You want to solve? You want to stop here?
Sure.
Sure.
Sure. Okay. We will try to finish 19.123 this week. 19.123 this week, and I want to give you a separate assignment on exponential function word problems. Okay. Do that separately. Exponential function word problems, and one more is from the book 19.123. We'll enter into polynomials next week. Okay. Yes, guys.
Bye.
See you all
Bye.
next week. Have a nice
Bye,
week.
Auntie. Thank
Bye,
you.
guys.
Bye.
Bye, guys. See you all next week.